Transportation. He is the headquarters level engineering automation section and is currently working on GNSS tablets for non-surveyors, contract specifications to support 3D engineered models, automated machine guidance, subsurface utility engineering, and ground penetrating radar. Prior to ODOT, he worked for 2 counties in one of the larger cities in Oregon. He has surveyed for planning, project development, right-of-way, construction, and everything in the middle. His past projects range in size from a 5 square foot fire hydrant easement to a 1,000-acre urban renewal district boundary. We all know that the small projects can be a little bit more difficult sometimes than the big ones. All right, Chris, I'm going to get you set up here.
Thanks for having me. My topic is not as high-tech and cool, but I still think it was a great project, and I'm glad you came to see it. So I'm Chris. I'm a professional land surveyor, and I work for our headquarters level, so I support all of the DOTs, surveyors, engineers statewide. So I've got a pretty big range to cover. And you already hit all my topics. So anything really cool or geospatially related is probably what I'm working on. We're the research and development group for our DOT, so we get our hands on all the good stuff. So I work at ODOT. We're the real ODOT, not Oklahoma, not Ohio, Oregon. We're pretty big. We still do a lot of work in-house. So we have 4,500 employees. We have about 8,000 miles of roadway. And we really, from the top down, we have a kind of a commitment to stay technologically relevant, stay on the cutting edge, keep in-house expertise. We contract out 70% of our work. I'm not saying we do everything ourselves, but we have experts in everything. And we try to keep that expertise in-house so we know what we're getting when we pay you guys to do it, or we know what we're doing when we do it ourselves. So what if everybody in your agency could go out and make high accurate measurements? We've had GPS at ODOT for 30 years almost. We started in the Stone Age, surveying at 2 a.m., 10 hours at a time, to today where everybody has a phone in their pocket. But we had a big divide between the surveyors and everybody else. And the problem is we don't have enough surveyors. I added it up right before I came down here. We have about 25 survey crews across the state to support all of our design and project delivery. And we're all on tight budgets and tight timelines, but we also have this just exploding amount of data that's available across our agency in all sorts of little locations. And we're totally committed to this 3D data. We have mobile LiDAR. We've got top-end gear. We drive on our own roads, collect our own data. We've got 400 terabytes of data on a server somewhere, mobile LiDAR data. We've got 3D design on every project we make. Every project that we ship out, full 3D design. You can load it right into your equipment and doze around. We have GIS for almost every asset we have. We have picked up some UAS technology so we can fly projects and get preliminary imagery overnight almost. But it's all stuck in silos. I have the GPS equipment. You can't have it. If you want to do high precision GPS, good luck. You're on your own. Call a surveyor. Get in line. Be 10 days, 2 weeks tops until I get there. And then the designers had the model. So if you were a heavy CAD user, you probably couldn't see the model or use it. And then the GIS guys just did GIS and they didn't play anywhere else. So it was a big challenge to kind of merge this all together and find some way for the end user to interact with this data. So we needed to make a big shift from the top down. We got some buy-in from our upper leadership that said we need to kind of break down these silos. We need to get data sharing. Perhaps we we can get high-end GPS out to more than just surveyors. Shouldn't be locked in the surveyor's cabinet or his truck. Maybe this is an idea. So we decided to just blow it wide open. We started with like a kind of pilot project in one group. We're going to say our construction inspectors, we're going to get them GPS. And while my boss wasn't looking, because he was about to retire, I made the executive decision that if you called me and wanted GPS, I'd probably get it to you. Right or wrong, whether my boss thought it was a good idea, why should I be holding back equipment from professionals in my agency just because they're not on the surveyor list? So we really just started over and said we got to come up with a new way. So we picked some new equipment. We searched high and low. We tested and demoed everything on the market. We have one brand for our survey crews, and they're all standardized. Everybody gets the exact same outfit. Their trucks are almost identical. We can interchange people in our 15 offices, and that works easy. But the technology and the solution that we solved there wasn't going to work for a biologist that works out of one of our local offices. We had to come up with something different and kind of think outside the box. So we looked everywhere, like I said, and we really found it in the back of a magazine. We saw this GPS tablet. We're like, nobody's ever heard of this thing. What is this? And so we brought in a demo and we tested it out, and we ended up picking a GPS tablet. It's all one piece, built in, survey grade, accuracy. You can use it handheld. You can put it on a rod and look like a surveyor. And it was really kind of a novel solution. And this was in 2015. So it was pretty cutting edge to roll out something. And what we picked was a DT Research tablet. And it's a rugged tablet, touch screen, it's super modern, big real estate on your screen, no more little 3-inch screen. It's big, color, and it's Windows. We're a Windows shop, everything's Windows. So it looks exactly like the people's desktops. There was no like, how do I open this? How do I operate this? Full Windows computer, so you just open up your survey program and go to work. Close your survey program, open up your PDFs, do whatever. And that really just sped up the timelines on how fast we could roll this out because we didn't have to train them a whole new system. Then we needed some survey software. So we went with MicroSurvey's Field Genius. If you've ever used Field Genius, it is super easy. It is the easiest survey software interface I've ever used, which was really important for these users that were going to pick it up once a week, once a month. Our survey crews use their gear every day, 8 to 10 hours a day. They know everything about it. I couldn't teach them something they don't know. But if they take a long vacation and maybe we upgrade the software when they're gone, they're sunk. They call the help desk Monday morning when things don't go right, because it's not always intuitive and it doesn't always work right. So there's the tablet. It really works in your hand. The receiver built into the tablet, the antenna stuck on the tablet. You can walk around, survey, that RTK accuracy, a couple centimeters. It's crazy. Everybody is blown away when they try it for the first time. There's a software. It's big, it's colorful, push buttons. But as much as I want to talk about the hardware and the software, I could talk about that for hours. That wasn't the revolution. It was just part of it. It was rolling it out to the people and changing their attitudes. We needed to kind of break down that wall between surveyors, have the high accuracy stuff, and everybody else gets GIS grade, 5 feet, or nothing. And so we just changed it all and said, you bring me a business case for surveying and for using this tool, I'll get you the tools, I'll get you the training, and we'll support it. So we started pilot projects. We bought 10 tablets, rolled them out to some very key places that I could support within an hour of my office. And then we gave them a ton of training. We overtrained them. And as training has gone on, it's gotten more refined, easier. We cut out a lot of the stuff we didn't need. They just didn't need to know it because it doesn't really matter in the end how much you know about GPS theory. It's, do you know what you're doing? Do you understand what's happening? And can you push the buttons and export the data? The people I was training are professionals. They're just not professional surveyors. They're professional biologists or geologists or construction people. They know their job. They know how to measure their things. They just didn't have a tool that was this accurate until I brought them something. Or they had a tape measure or wheel, or they'd call the survey crew. So we rolled it out small, trained them up, and supported them. They called me, they texted me, emailed me whenever, and we'd be there for them. And that was really crucial in the beginning to almost provide immediate on-call support to these people that were new to it. They couldn't just go to somebody else in an office and say, hey, how do I do this? Because they hadn't been doing it for 10 years. They hadn't been doing it for 20 years with similar equipment. So we hit them in the classroom with training. We hit them outside with training. This is one of our offices, and I would show up at their office on a Tuesday. I'd set up a classroom outside, pound stuff in the ground. Wednesday, we'd spend all day surveying. And by Wednesday afternoon, they were proficient, they were ready to roll. We got it down to about 6 hours of face-to-face hands-on training. And it really changed their ability to think measurements. They were able to think, how can I do this now compared to how I did it before? And a lot of these people had been measuring things or marking things that then a surveyor would have to come measure for years. And they understood the process, and they just needed a tool. And we got them a tool, we got them the training. So how does it really work? The hardware, it's all built in, one box, turn it on, it goes. But we have a huge advantage. We own our own real-time network, GPS base stations, got about 90 stations across the state of Oregon, covers 99% of the populated areas, and 90% of our roads are covered. So we didn't have to figure out how are they going to get a survey corrector? How are they going to set up a base station? We just dial them into our network with the built-in cell modem in the tablet, or they hotspot it to their iPhone that everybody gets on about week 2 of the job. So hotspot or the built-in, and they go to work. And it does it all back end in the software. And that was, we set up our real-time network years ago, and it was for our survey group, and it's free to everybody in Oregon, and so if you're a surveyor there, you get it and use it. But we've never considered rolling it out to the rest of our agency. How can we harness this technology that we've used, and we paid $500,000 a year for, to more than 25 guys with rovers? So we just blew the doors open, and I said we had 25 outfitted survey crews around the state. In about 2 years, we went from 0 people outside of survey having high-end GPS to now there's 75 of these rovers running around. So I've tripled up on the survey crews on how many high-accuracy GPS units we have rolling around the state. And what's really the critical component for us that we had to have when we set this up, these new rovers had to work on the same coordinate system that our survey crews were collecting the data in, our designers were designing in, and construction was building in. Had to be on the same system. So we found a software that had our Oregon coordinate reference systems all built in. It's just a checkbox, and you can set up a project and go to work in about 45 seconds. It's crazy simple, and it's really just blown the doors open on what we can do in the field. And it's easy to use and operate. If I had a tablet on me, I could take somebody outside, and in under an hour, you'd be proficient regardless of your level of GPS or surveying background. In an hour, you could be measuring and mapping right out front at the convention center, I'm pretty sure. And it took off. It started with our construction offices. We have 15 construction offices spread around the state. It started there. I got units into all the offices, went to everyone, trained them, kind of held their hands for the first 6 months or so. And then the calls started coming in. we all worked together on projects and on sites, and so everybody was seeing these new pieces of hardware. They're like, what is that? How do I get my hands on that? And they'd call me, and I'd get them something. So we have biologists, or utility people, geologists, we have some in our maintenance offices, our UAS guys picked them up because they're so easy, and more. And I have emails from while I was here from people that want to get into it. Somehow I thought I'd hit everybody in our entire state. I thought I'd talk to all 5,000 employees, but apparently there's still people that don't know about my project. So they're still calling me up. So what are they doing with them? They're measuring anything that you can measure with clear sky and GPS. And I had thought up this very niche little area. Oh, they'll do these like 5 tasks. So my initial training had them with these 5 tasks. The users themselves have been coming up with all the ideas. They come to me and say, how would I do this? How would I do that? And I work back and forth with them, come up with an idea, and then harnessing the power of email, I email it to everybody that has a tablet. This is what so-and-so learned. I don't use their name so it protects them if it's a bad idea. I blast out to every user. And so everybody then learned from what they learned, or what workflow we just developed, and maybe I put together a 2-page PDF. Everybody now has that PDF. They can refer to it today, tomorrow, in 6 months. We're like, oh wait, Chris sent me something about that exact process. Here's a cookbook, go to town. And then it's really bumping into our asset management people who have had the GIS grade gear for years. And every year we do a inventory because we're the state and we can't help count stuff. We count how many GIS handouts we have out in the field. And every year inventory time, people are like, well, you can take those back. We don't want those. We got the tablets. So it's replacing old gear, outdated gear, improving processes, and the users came up with it. They self-selected to get something. They self-selected to push it out. So it's growing naturally outside of like the construction and the areas we thought of, but it's just taking over. And it's a full computer, so you can do your email, you can do your web browsing, you can watch YouTube, whatever you're not supposed to be doing at work, you can probably pull it off on the tablet. But we're getting into more of the stuff we hadn't thought of, and it's really been cool to see it all go down. They're easy to use, they're versatile. You can put it on a rod, look like a Surveyor, go handheld, super high tech, confuse everybody, and then when you tell them, oh, I'm about this accurate because I'm using a handheld, they're like, it just blows their mind that you can have RTK GPS in your hand. I say maybe in 5 years your cell phone will do that when all the next generation GPS satellites are up. But in the meantime, this tablet is years ahead of where I thought we'd be. It's crazy. We can do construction inspection, measure quantities, locations. They're on some curb and gutter. They're not measuring elevations with GPS. We know our limits. But on the rod, so it's 3/400ths in the horizontal and 6/700ths in the vertical. So you're not going to call curb on or off based on GPS, and we know that, but we can sure count it and measure it and quantify it and make sure it's the right location with GPS. And then it's permanent. We had thought of all these uses and all the reasons why GPS would be better and faster. The permanence and the right or wrong, people see you using GPS, collecting it, recording the data, making a map, they buy into it. So all the third-party people that come in contact with this data are like, oh, you GPSed it, here's your data, it must be right. Claims gone down, arguments with contractors gone down, rework, remeasure, it's all disappeared. We just don't have to do it. We record it, capture it permanently once, everybody buys in on it. It's really pretty slick, and how fast that happened. You can do volumes with it. It's not rocket science. It's really simple, and you can get the quantity in the field, which is a huge benefit to our old process where you call the survey crew, get on their list, they'd get out there in about 3 weeks, they'd shoot it all, they'd take it back to the office, they'd send it to a designer, he'd crunch it in CAD, you'd get a number, maybe a month later, you'd have your number. Takes about 45 minutes. This is the pile I'm on there. I think it's like 35,000 or cubic yards. A huge pile. It's 45 minutes from when I turned off the truck till I had a number that I could email to a project manager. And that's it's pretty standard. People figured it out. People were figuring it out on their own before I was teaching them how to do volumes in the field. It was that intuitive to do it. And then our wetland people and our biologists and our foresters and our archaeologists, they're super trained professionals. They know how to make maps. But traditionally, they have been paper maps. They put flags or paint on the ground. They call me, and then I go tie those. I tie them in the wrong order, so then we got to adjust it, and then I have to go back a second time. So now there's 3 days of crew time for this map, plus the 2 days of the biologist time to go out there and actually mark it. Why don't we have him do it the first time? So our guys and gals are out there mapping their own resources now, one time. They're not time flagging and ribbing and marking it and sketching it all out. Now I don't know about where you live, but if you stick a lath in the ground and there's kids, they pull them out in their swords. You tie flagging out in the woods, the deer and the elk, they come eat it, and it's all gone. So inevitably, there was rework. We had to go back and do it again. So now these professionals, who are trained professionals, they are signed off to do all sorts of work and map their own stuff. I just got them a better tool, and they can do it themselves. The only problem is now, they go out with their whatever federal agency has their oversight for their audits, and they walk the projects. Now these agencies expect it to be spot on. They expect to be able to find the soil test holes. Where before, you'd go get within 10 feet of where you dug your test hole in the past, and you'd dig another one. Now they can go to that same test hole and pull the plug out, the grass plug, and put it back. They're like, yep, that was your test hole. I buy in. So now people are disappointed when it's not spot on survey accurate. Doing some wetland restorations with it. They're actually constructing new wetlands and using them for location, construction, drainage, telling the guys where to dig. And these are just the biologists. These are the staff that would be on site anyway, directing the work and telling them where to plant. Now they can do it all. They don't need to set up a laser. They don't need to call in somebody with a total station. They're not translating paper to ground and then adjusting it by eye. They can mark out exactly where they want it to be dug and dig it once. And then they start a grass fire, and we watch and wait for the fire trucks to show up. And it's super rugged. You can haul it up and down these landslides. I know in California you get rain and you get landslides. We have the same problem. Everything's moving downhill, and we're always working on them. And now we have a tool that can just bounce up the side of the hill and get some shots and see if they're getting it in the right location. So what did we see as a benefit? How did this really help us as an agency? We put the tools in the expert's hands. We shifted the work from a multi-step where it's passed along to the expert gets their own data the first time. We reduced our timelines. Now stuff can be done in a day. You can have a wetland boundary captured and into CAD in 1 day from identifying it into the computer. Increase our accuracy. Now we're not trying to interpret what somebody else wanted us to measure. They measure it themselves. Better documentation because it's permanent. There is no hand sketches. There's no, did I measure from here? Did I get here? It's documented, it's permanent, it's digital, it's reproducible. I could send you a file and you could go stake it out and you'd get the exact same locations that I did. And it really changed people's minds. So we have all that massive amount of geospatial data. Now anybody can take it out in the field. They can load a CAD file and go look at it. Our right-of-way people who do right-of-way purchases and easements, they can now take the plans in their hands digitally, georeferenced, walk around and say, yes, this is where the new back of sidewalk will be. And the homeowner nods, looks at the digital plans, looks at the piece of paper, which is their vesting deed or their document or their proposal, which is all text and doesn't make any sense unless you're a surveyor. We make it cryptic so they can't catch us if we're wrong or something. They're like, yeah, this makes sense. Oh yeah, this makes way more sense than this document that cost us $10,000 to produce. And now we spend 15 minutes with them on site, and it solves all the problems. And then we can take our mobile scan, our LiDAR data, anything we've extracted from that, boom, into the tablet, out to the field. So now people can work both ways. They can capture data and send it back to the 3D model. They can take the models outside. They can interact with all this 3D data we have down to that survey accurate positionings. So they're asking a lot more questions. What can I do with this? Can I do that? How would I pull this off? And it's really just making the whole process easier for everybody and opening up a bunch of ideas for our whole agency. So cost, what does it really cost? How do we pull this off as a state agency who has super tight budgets? I don't mean to disparage anybody's company, but this stuff is cheap. I don't know their business model. I'm not received as much as a pen or a complimentary hat from anybody that I buy from. But it's so inexpensive, we almost consider it disposable. Compared to our survey grade gear, which if you wreck it, you're in big, big trouble. I don't even care if they break the stuff. We'll just buy another one. For the whole kit, the tablet, the cases, the training, the software, everything, it's cheap. Adding my support time, and even all my travel all across the state to deliver it, in 3 years, it's like $12,000 a unit for hardware support service for the life for 3 years. And next year that's going to get a little cheaper, and then after 5 years we're going to buy new ones and upgrade them, and so the number will go back up. And considering that we bill about $1,500 a day for a survey crew, it doesn't take long to pay for themselves. If your project doesn't have to call the surveyor 5 times in the length of its project, you probably pay for your unit in 5 days of survey crew work. If you catch one bust on a construction project, the change order or the claim probably just paid for it. And even if the stuff is total junk and we throw it all away, we still have the software that we can put on something else. We still have half the hardware is interchangeable with all the other survey gear in our office. So it's not like it's just, the money just disappears. So we very quickly and easily justified it and went from 10 units to 75 units almost overnight. There's a map of all of our construction offices. We're hiring. If you want a job, come to ODOT. Those little blue lines are all the roads I drove to roll out this project. It's about 7,000 miles of driving, and stayed in a lot of crummy hotels in Eastern Oregon. But it's a beautiful state. You should come check it out. And if you want a job, ODOT Jones. We're looking for engineers, surveyors, everybody in between. Thanks.